Hello friends, in this video I'm going to talk about a very foundational model of machine learning, and that is called linear regression. With the help of this model you will be able to understand the concept of independent and dependent variable. So let's move on to the numerical implementation of linear regression, and then I will put this whole thing into program using Python. So over here I have got two data set. One is called hour study, represented by the variable x, and value over here are like 1 2 3. These are like the hour I have studied. Well, I'm a student, so I'm considering this to be like if I study 1 hour, my score would be 50. Similarly, if I study 3 hours, it would be 60, and if I study 5 hours, it would be 70. So x represent the number of hours, and y is the score that I will be getting if I study this many number of hours. So from here one can understand that x is very much independent, while y is very much dependent on the number of hour I'm studying. So one can say that y is a dependent variable while x is an independent variable. Now I want to make a best fit line, or I want to come up across an equation where I will plot the number of hours and it would tell me what would be the test score, and that's what I'm trying to do in this equation, or in this model. So for that reason the equation which I will be using is y equals to mx plus b. So for that reason we have to calculate the value of slope separately and value of intercept separately. So for calculating the slope we would be using the following formula, and each of the unit we will be identifying them individually, and then we'll put this into the formula itself. So first thing what I need to find out is the summation of x. Summation of x means the sum of the hour I have studied, and that is 1 plus 2 plus 3 plus 4 plus 5 would be 15. Similarly, sum of the y is the test score, so I would be going for summation of them and it would give me the value 300. Now I would be going for the sum of the squared, so sum of the x square, so xi square rather, it would be 1 plus 1 into 1 square plus 2 square plus 3 square, and that would give me the value 55. And finally I will be going for the product and its sum of the product of hour and study. So 1 into 50 plus 2 into 55 plus 3 into 60 plus 4 into 65 plus 5 into 70, we would get the value as 950. So once we have got all these four units separately, now we can plot them directly in the equation. The equation of the slope is n. Well, n is the number of rows you have got in the data set. Over here I have got 5 rows, so n would be 5. So n into summation of xi yi minus summation of xi into yi upon n into summation of x square I minus summation of xi whole square. So let's put them individually. So the value of n according to the data set is 5, so I put 5 over here, and then we are going for xi into yi. Xi into yi, we already got the value 950, sorry. So we will go for the summation, and yeah, summation is 950, so that would be 5 into 950 minus xi. What is the value of xi? Xi we have got 15, and yi we have got 300, so we are going for the product of that. So 15 into 300 upon n is 5, and summation of x square I, so x square I is this one, is 55, so 5 into 55 minus summation of xi whole square, so xi whole square is xi means summation of this, right, is 15. So summation of xi is 15 and its whole square, so 15 whole square we have to put over here. So eventually we will be getting the value what we have seen over here, 4750 minus 4500 upon 275 minus 225, and eventually we'll get the slope as 5. So that's the formula we have to implement, and we would get the value of the slope. So remember this, m equals to 5. This is what we will be getting once we calculate the slope or the coefficient. We can call it as a coefficient also, because when we implement this model in the Python, we will find over the term coefficient is mentioned. So m equals to 5. Now let's calculate the intercept, and we already have the units for which the intercept can be easily calculated. The formula for the intercept would be summation of y minus m into summation of x by n. So what is the summation of y? Summation of y means sum of the score. The sum of the score is 300, so let's put that, minus M stand for the slope, which we have already found in the previous value. So we put the value 5 over here into summation of x is 15. So 5 into 15 upon the number of record we have got is 5. So that's come over here and we would get the value 45. So y-intercept is actually 45. Now we can put the equation in this form. So the best fit equation would be y equals to 5x plus 45. Now it is a very nice looking figure we are getting over here, because we can put the value of hour over here. So x represents the number of hours. So if I put the number of hours, I can easily calculate the score what I would be getting. Now what if I don't study at all? I'm not that bad student. Although if I don't study at all, so if it is 0 hours, so at least we would be getting a score of 45. I wish that would have happened in the real life, but that's not going to happen. Nonetheless, so if my hour of study is 0, I would be getting at least the test score of 45. In the same way, what if I study 6 hours? Then 6 hours means 5 into 6, that is 30, plus 45 would give me 75. So that's the score which we would be getting if, depending upon the number of hours what we would be studying, according the score would generated. As I already said, the linear regression is one of the best basic model of machine learning, where we will be come across the independent variable and dependent variable. So we saw that if we put the independent variable, we can calculate the dependent variable, and for that reason we need an equation, and that was already been provided right over here. So this was the complete numerical implementation of basis of the following data set. Now what if I do this in the real program? So I have just written a program based on this exact value over here. So let me share you the program now, and for this I have to implement certain packages. First I need NumPy, I need Matplotlib because graphically I have to represent the graph over here, and also I need sklearn for getting the model linear regression. So as I said, I will be having an independent data set, and that is what I've written np.array. So we are converting this particular value into a NumPy array, and this is the value which I have given. Well, I have randomly placed the value. You can put it accordingly also, no problem. So if I study 5 hours, it would be 70 score. If I study 1 hour, it would be 50. If I study 4 hours, it will be 65, as you can see in the figure. So that's the way I've written. You can put it in you can put it in sorted order, you can put it in unsorted order. That will not have any effect on the model itself. And over here, the second y is also an array of NumPy, and where we have placed the test score accordingly, right? So these are like the single dimension array, but the way linear regression model actually works, it needs a double dimension array. So we have to go for the reshape. So we have to reshape our independent variable, and for that reason I gave a call to reshape function -1, 1. What does this will do? Well, this is going to create one particular column, and this will have 5 different rows, where each row would have individual value. So 5 will be one row, 1 is going to be another row, 4 is going to be another row. So it will be one column, and that would have 5 rows, and that's how the x will be regenerated rather. So it is very important part of the linear regression model. We have to convert our single dimension NumPy array into a double dimension. Okay, so once we have done that, now we can create an instance of the linear regression. We are giving a call to the constructor over here. As you can see, the package name, the method name, both are same. So we are giving a call to the constructor, and this is the object that is getting framed, that is called model. And now what I'm doing is that I'm giving a call to the fit function, so I'm passing the independent variable, the dependent variable, and that's how the model get initialized. So here I declare the model, here I've initialized a model. Now I'm going to find out the coefficient, that is a slope, and here is what you have to write. So model.coefficient, this is going to give a data in the form of an array, and the very first index I will be getting the value of the coefficient. So for that reason I would be writing model.coefficient within third bracket, that is 0. Remember, this is an underscore over here, coefficient underscore within third bracket, write 0, and that would give me the slope value. So what the slope value we have got? We have got the value m as 5. So if everything goes well, if my numerical operation has been done correctly, I would be getting a value that is slope is 5. That's what I'm expecting. Similarly, the intercept, model.intercept, what I got, the intercept was 45. So if everything goes fine, I will be getting an intercept of 45. And then finally I wanted to represent the expression at the best fit line, that is y equals to 5x plus 45. This is what I have written in my numerical implementation. A similar thing I want to do it, but over here slight changes I have implemented. I have gone for the floating point, so the value would be in the point of fraction. So it would be like y equals to 5.00, because couple of set precision I have done, couple of decimal places, 2 decimal places I have gone for. So 5.00x plus 45.00, something like that. I'm expecting, I don't know, I'm just expecting. Okay, and finally I'm going for the prediction. I'm going to be, and then after implementing this, I want to show the line, the best fit line in my plot, in my graph, and for that reason I have gone for the model.predict. Based on the x, which is my independent variable, the prediction will be done. That means the y will be generated on basis of the prediction. Okay, and I have plotted the data point in the scattered plot. Over here I have gone for a scatter, and then the data point will be plotted over there, and then this will draw the line of equation. For me, the best fit line of equation will be shown, and some labeling has been done respectively, and finally I'm going to show the plot. Okay, it's a long story altogether, isn't it? Now let's run the code and let's see what happened this time. So let's come over here and let me clear the screen first. Yeah, the screen got cleared, and let me zoom it a bit. And now what I'm going to do is I'm going to run my program. So python prog.1 python prog.py. I hit the enter, and I'm expecting to see the graph, okay, and the plus this particular line, the best fit line I want to see. So let's hit the enter and let's see what happens. Oh, I made a mistake. I went out of my environment. For that reason this happened. So let me get back to my environment. So just a second, let me clear the screen. So let me see, where am I right now? I need to go out of this, and ls it will take me to Django. Yes, here in the Django I have got my environment, and cd env environment is there. It will take me to the environment. Yes, and now I can start my environment. Source activate. So I will be activating my environment. Just a second. I need to go to the bin directory first. My mistake. I went to the bin directory. So source and activate. Yes. So I activated my environment because everything I've kept inside my environment. For that reason I have to do this. And now let's come back from the environment, cd out of bin, out of my environment, out of my Django folder, and now I will go to the program folder. I have the folder called linear regression, so I will straight move to the folder called linear regression. Linear, yes, fine. And now let's clear the screen, and here I have a file called program.py, which is this particular program. So now I can easily run my program. So python prog.py and hit enter, and here the thing comes up. Here is the thing that I was expecting. Look at the thing very minutely and look at the equation. The equation which I said it would be in the form of 5. See, the slope was 5, and look at the equation, the exact equation which I have found here. Also same thing comes up. So y equals to 5x. I said it, I want to represent in the floating points of 5 into 2 floating point representation. X is the value which I've given, plus 45 is my intercept. So exactly what I have done in my numerical operation, the same thing Python is even predicting based on the data set what I have given. And look over here, the matplot, how nicely it has plotted. So what I said is that if I study 1 hour, my score would be 50. That what I have mentioned, exactly that is so. If I study 2 hours, my score is going to 55. That also come. If I study 3 hours, my score is going to be 60. Exactly that what has been shown. If I study 4 hours, it's going to be 65. And lastly, if I study 5 hours, I would expect 70. As a student, I must study at least 5 hours. Don't you think so? Okay, so that's how the entire thing worked out, and that's how we saw how scattered plot has plotted these things, and how the predict function has implemented this sweet line, best fit line, and we have seen that even, and how is this the numerical operation, the function, the formula which are implemented for slope and intercept. I have written them, and eventually we got such a nice output, and this equation, the best fit line, we have also seen. So from this video we did understand that how independent variables are going to influence the dependent variables and how they are interrelated, and this all I have done using the linear regression using sklearn package of Python. Okay, so that's all from this video presentation. In my next video I will be working more on this, and I expect to convert this particular program in a more dynamic form, and for that reason I will be using Django, because I want the users to give the input, not like the way I've taken a hard code input. Okay, but first, for the time being, at least if you do this, you will be able to understand how this particular model is working, and when you go for the Django implementation, what better than that? Okay, so let's wait for that video. Until then, have a nice time. Take care. Bye bye.